Hey guys, welcome back to the shop. So today's project is a log splitter, and this is a Forest King 22-ton log splitter. 22-ton, and it has a Maxx LCT 4-stroke motor on it. I think it's like a Korean or Chinese made clone of a Honda motor, but the motor runs and the pump works and the cylinder is good, the valves are good, so the hydraulics are all working, and it has the towable kind of chassis, and this is the style where you can actually tilt the entire thing vertically, and that's actually how I prefer usually to run these, but it's got a lot of problems, so we'll take a closer look. So this is the splitting wedge here, and this is the end of the hydraulic ram, and there should be a socket here that the ram engages, and it's sort of a floating joint. It has a pin that goes through it. That's all been torn off, and you can see I don't know how many licks with a 6-pound splitting maul it takes to destroy that wedge, but they were getting pretty close. And then the top plate here of the H-beam it's worn about halfway through its thickness, and it's kind of curled up like this, and it's also got a pretty good camber this way. Now it's got these kind of built-in cradle things that are, I guess, supposed to hold the piece of wood, and then these here are like stops, so when you run the wedge all the way back, if it's stuck in a piece of wood, these stops are supposed to hold the piece of wood while it pulls the wedge out. It's a pretty common problem with log splitters, but you can see it's been cut and welded, cut and welded, cut and welded, and there's not much left. So the hydraulic valve is working fine. This is a simple valve. It's just got inlet pressure from the pump here. There's one connection to either side of the piston in the cylinder, and then the tank return line there. And it has a detent that locks it in the retract position, and it does work. The handle's bent, and they put this lovely golf ball on the top of it. Here's the motor. So the motor runs fine, but there's some crusty things. This heat shield on top of the muffler must have fallen off at some time, and so they just like stick welded the heat shield, and then they welded over top of all the bolts. So I don't even know how I'm going to get that back off there, but anyway, it won't affect what we're doing today. So here's a look at the top of that beam. You can see just how badly it's worn and bent. So we definitely have to do something to fix that. That's the primary objective today. So the story with this log splitter is that it belonged to some farmers, and they brought it to my dad to see about getting it fixed up. And so my dad has a small shop, more or less like mine, but he primarily works on farm equipment, agricultural type stuff. And he told him that he could fix it, but that when he got done, it was going to cost him almost as much as a new one, and that they were still going to have a machine that probably wasn't really matching their needs. So I've worked around a lot of farmers and for a lot of farmers, and generally they're good people, salt of the earth, but they just know how to get every plug nickel out of their equipment, and this thing has just been run to death. I think they were more or less running a commercial firewood operation, running this machine like 8 hours a day, and this is like a homeowner type log splitter. It was never designed for that kind of work. So they bought a flywheel rack and pinion style log splitter. I think it's called a rapid split or something like that. Anyway, it looks like a killing machine to me, but it's definitely a lot faster. And then they chose to retire this machine, and I was able to buy it from them for scrap price. So it wouldn't make sense to fix this for somebody as a paying job, but for my own purposes, should be a pretty simple task. Well, as luck would have it, I just happen to have this section of S-beam here, or what we normally call an I-beam. Now the splitter is made with an H-beam 6x6. This S-beam is like 5.5 by 8.25, something like that. So it's not going to be an exact match, but I think it'd be close enough that we can make it work. And this has got quite a bit more strength. You know, it's got more section because this beam is, you know, another 2 inches taller, and it's also slightly thicker in the flange and the web. But there's going to be a few issues trying to make all these things marry up. The biggest problem is that this beam is about 3 inches too short, so I'm going to have to come up with something clever to either reduce the stroke by 3 inches or somehow stretch that thing in a creative way. Like that was going to work. Yeah, right. Well, this will be fun. Probably gonna end up torching all these bolts off. Jesus. Yeah, by the way, if you're looking for a good way to screw up the grips on your vice grips or channel locks, sticking them on the opposite side of an impact wrench is a pretty good way to do it. Luckily for you, I've already destroyed these. Oh. Yeah, not gonna happen. There we go. Wow. Look at how bad it's damaged down here at the bottom of the stroke. Couldn't even see that because the wedge was stuck there. Okay, I think I changed my mind about how I want to fix this. The the problem is I had to re-engineer this foot and the cylinder mount bracket. All that stuff has to be re-engineered if I change to a taller beam. Also, the flange thickness on this beam is 3/8, and on my other beam it's actually a little bit less. It's like 5/16. So anyway, what I think I'm going to do is I'm just going to chop this top plate off of the beam, and then I've got a piece of 1/2 inch plate. I'll cut out a piece of 1/2 inch plate and basically weld it in as a replacement for the top flange of this beam. It'll be a lot of welding, but I won't have to re-engineer all of the attachments to the beam. That would be a lot of work. So the foot's in good condition, the mounting bracket's in good condition, so I don't see any reason to re-engineer all that, changing all the brackets and everything, when the only thing that's damaged is this top plate. Now there is a little bit of a bow to the actual beam, and I may be able to pull that back once I remove the top plate, but more likely I'm just not going to worry about it. It won't hurt anything. So that's the plan for now. Okay, the top plate is removed, and it's not the cleanest cut, but I think it'll be just fine. So now I'll cut a piece of 1/2-inch plate to go in its place, do my best to straighten out this cradle thing, and then weld everything up tight. And actually, I'd say at least half of that bow in the beam came out just from removing that top plate. So I'll bet anything that by the time I weld it, the weld pulls that back together, that we're going to be perfectly straight. Okay, I cut the plate and got it sitting in there. That's the rough outline of what it's going to look like when we're done. Except I need to call in and get my machinist calibrated eye recertified, because this plate is actually 3/4 of an inch thick, so 19 millimeters. So it's basically double the thickness of the original web. And if we screw that one up, we got a way bigger problem. Also had to go at straightening these cradle brackets, just BFH, and they look pretty good. So I am going to get things cleaned up and do a lot of welding. Alrighty, we're all geared up for welding. So I've got the ratchet binder and a chain here, and I'm just kind of pulling the thing together, and that's taking almost all that bow out of the beam. So I'm hoping that by the time we get things nice and hot and welded, when I relax that chain, it's going to stay more or less where it is. So we're going to MIG weld this. I got the old Millermatic 200 out. We're going to be pushing her to the limit, I think. This is a 200 amp machine at, I don't know, 40% duty cycle or whatever they're rated at. And we're going to have to burn this in good and hot. And a little challenging because we're trying to weld a 3/8 thickness web to a 3/4 thickness top plate. So we'll have to see how it goes. Plus it's out of position. Probably I'll tip it up and weld it vertical down. Yeah, I never knew you weren't supposed to do that until I watched that Brian Blocks video recently, where everyone chastised him for welding vertical down with a MIG. That's how I've always welded everything. So, news to me. Well, let's get to it. Okay, we got her welded. Sorry, it's really hard to show this on the camera. Out of place, upside down. But yeah, she's been welded the full length, both sides, and yeah, there's nothing wrong with that. So the original design, they had a bracket across this kind of corner, so I cut some out of 1/4 inch plate, and they're just going to tuck in there, and then I'll weld that on all 4 sides, and there's one on the opposite side, same thing. Okay, so I've bodged in some new bars here, 3/4 by 1.5 inch this time, for that mechanism to clean off the wedge if you ever get something stuck there, and did my best to straighten these little brackets. It's not the greatest. I probably should have cut some new ones, but I took the easy way out. Okay, nice big weave pass on the top here, and then I got the angle brackets welded in either side, and I think that we're done with the welding on the actual frame, and now I have to work on the wedge. So I took this is a spacer that goes underneath of the wedge, and I cut another piece the same size out of the old section of I-beam. So the spacer, the original spacer was 1/2 inch. This is 3/8, so that'll get me to where I need to go as far as thickness. I think since the top plate is 3/4, having a 7/8 spacer give it a little bit of room to move around. And this is some kind of weird hole pitch. I don't know what it is. These are just punched holes, but it doesn't seem to match up to anything in inch or metric. So I just welded the two together, or tacked them together, and then I'm going to use these holes as a template, and we'll drill them 17 30-second holes through there. Like so. The bottom of the wedge here has some wear on it where it's just been riding on the top of that beam, but it's not substantial, so I think we'll let it go. And then these are the old plates that were on the bottom here, and they're extremely worn, but I think what I can do is just flip them around. So I'll put the unworn portion to the inside and we shouldn't notice any difference. Going with the proper made in USA 1/2-13 bolts. You know, people think that there's nothing made in the US anymore, but it's mostly just because they're too lazy to find it, and when they do find it, they're too cheap to buy it. Okay, I got the socket all welded on. I got the wedge mounted. The only thing I really should do is clean up where they beat the hell out of this wedge, but I'll do that a little bit later. And then, you know, it probably needs a coat of paint, but we don't worry about that right now. So I'm going to fire it up and see if it strokes, and then we'll have to wait till tomorrow to give it a proper shakedown. So one problem I have is that all the controls, you know, the stickers and stuff on the motor are worn off, so I don't really know what the various levers do. I mean, one's a choke, one's a throttle, and one's a, you know, ignition switch, but I'm not sure which position is full or off, so sometimes it takes me a little while to get it started. Okay, it's hard to argue with that. I think we're in business. So tomorrow I'll take it up home and we'll test it out on some pin oak or something nasty. And then I definitely need to clean the shop. Looks like a Bangladesh shipbreaking yard in here. Yeah, you didn't believe me, it was owned by a farmer? Proof. Right there. Much better. So I took a stab at trying to fix the top of this wedge, and it's not the greatest repair, but it'll be okay. I think there wasn't much I could do, so I'm sort of straightened what I could and filled in with weld what I couldn't, and it'll be fine. Most of the stress is out here. This is just kind of to open the thing up. So I didn't want to leave it like it was because it seemed like a good place for, you know, the wood to get caught. Alright, I removed and straightened the lever, and then I knocked the old crusty golf ball off and welded on a short 3/8 stud. And then I have this plastic knob that's been kicking around my shop for years and years, so be a good place to use it. It's probably a little bit small, but It'll make me feel better than grabbing that nasty golf ball. Yeah. There we go. Much better. Hey, pup. Okay, I've got the splitter at my house, and I've been doing a little bit of work with it. Seems to be fine, so let's give it a whirl. We got Max here to supervise, so what could possibly go wrong? Okay, I think we've got a winner. It seems to have plenty of power, and the repairs look excellent. So, yeah, thanks for watching, guys.